So today what we're going to do is go through one of these linear programming problems. And what I want to do is sort of outline how to go through this problem from start to finish. So I'm gonna label steps as we go, and then also do those steps in this example. So the example we're going to work with here, theater is presenting a program on drinking and driving for students and their parents or other responsible adults. Proceeds will be donated to a local alcohol information center. Admission is $8 for adults and $4 for students. However, this situation has two constraints. The theater can hold no more than 180 people, and for every 2 adults, there must be at least 1 student. How many adults and students should attend to raise the maximum amount of money? What I'd like to do is to start looking at this problem from like an overall perspective, right? The first thing that we want to do is identify what our goal is. Okay, so we're going to identify the objective function. That's the thing to be maximized or minimized. And in this case, that's going to be the money raised. Okay, so if I want to write a function for that, the money is going to be dependent on how many adults and how many students attend. Okay, so in the process of making this objective function, I want to label some variables. So we're going to let x equal the number of adults, and y equal the number of students. Okay, and in the problem it said that admission is $8 for adults. So if 1 adult attends, that's $8, 2 adults, it's $16, right? So the number of adults times 8 is the amount of money that we get from the adults. So 8 times x. Likewise with the students, the admission is $4 per student, so I'd have 4 times y, and I add those together to get the total money raised. Okay, so that's my objective function, and to put this maybe in the notation that we've seen for some previous problems, we could write this as like a z equals, where z is the amount of money. And here's my objective function. Okay. I also want to identify the constraints. Okay, so in the problem it said that we had 2 constraints. The theater can hold no more than 180 people. Okay, so what I'm going to do is say, well, x is the number of adults, y is the number of students, so the total number of people is x plus y. And the theater can hold no more than 180, so it could hold 180 or less. So x plus y has to be less than or equal to 180. Okay. Then there's this trickier one. For every 2 adults, there must be at least 1 student. That constraint we can figure out. What I want to do is show you maybe a process for figuring that out. If you have a constraint, or any sort of sentence that seems a little bit confusing, one thing that I find helps people figure out how to turn that into an equation is to try and put some concrete numbers to it. So, for example, it would be perfectly okay if we had 2 adults and 1 student. Okay, and the constraint is that there must be at least 1 student. So we could have more than 1 student. Okay, so this is fine. 2 adults and 3 students is fine. Okay, 3 adults and 1 student is no good. Okay, so when I create my inequality, I want to make sure that it sort of matches up with this. Okay, and when it says, there must be 2 adults for every 2 adults there must be at least 1 student, I think that a natural inclination is to say, okay, 2 times adults, okay, and 1 student, and it must be at least so we can have more, and we say, does this work? But when I try the numbers, if I put 2 in for x and I put 1 in for y, right, then I get 4 less than or equal to 1, which is not true. So this is not the inequality that really represents that, okay? Because what I want is for every 2 adults, okay, I have to have at least 1 student. So if I want to think about parity here, there's going to be twice as many adults as students, or I have to cut the number of adults in half to be equal to the number of students, okay? So we could think of it as 1/2 x, or you could think of it as x is less than or equal to 2y. And now if I check this equation, when I put in 2 for x and 1 for y, they're equal. 2 for x and 3 for y, that makes the inequality true. Both sides aren't equal, but the right side is bigger, and that's fine. If I put in 3 for x and 1 for y, that does not make the inequality true, which lines up with what I want. Okay, so this is what we're going for here. Okay, so x has to be less than or equal to 2y. There are 2 more inequalities that are not mentioned anywhere in the problem, but are just sort of inherent in what we're doing. We can't have a negative number of people, so x has to be greater than or equal to 0, and y has to be greater than or equal to 0. Okay. So we've identified and written down our objective function, and we've identified and written down our constraints. That's our first step, okay, out of probably 4. All right, step number 2. Now that I have these constraints written down, what I want to do is graph them. Okay, so because I have x greater than or equal to 0 and y greater than or equal to 0, I know that on my graph I only need to really worry about the first quadrant. Okay, and I'll go ahead and put those in because they're nice and easy. So here's x equals 0. I want x is greater than 0, so I want the right half of that. Okay, here's the line y equals 0. I want the y is greater than 0, so I want the top half of that. Okay, and then let's go ahead and put in our other 2 more interesting inequalities. X plus y equals 180. So what I'm going to do is find the x and y intercepts. So when x is 0, that's just y equals 180. When y is 0, that's just x equals 180. Okay. Before I graph that, though, I want to look at the other one, and that way I might have a better sense of scale. So I'm going to look at x equals 2y. Alright. When I try to find the intercepts here, if I plug in x equals 0, I get y equals 0. So if I plug in y equals 0, I get x equals 0. I don't get a second point. So we have to pick something else for x. And just looking at the scale here that I have with x and y, they're in the hundreds, so maybe I'll pick x as 100. Okay, so 100 equals 2y, so y is 50. Okay, that's an option. You don't have to pick that point, but it just gives us some numbers that are at least in the same ballpark as the green line, so that when I go to graph them, I can get points that make sense. Alright, so we have 0, 0, and we have 100, 50. Okay, and I want to connect those with a line. Okay, and normally what I do to figure out which side to shade is I test 0, 0. But since 0, 0 is on the line, that won't work. So I'm going to test a point that I know is not on the line. I'll pick 0, 50. to test this into my inequality, x less than or equal to 2y. So I have 0 less than or equal to 2 times 50. That's true. So I want the side that contains the point 0, 50, so the top side of this line. Okay, and for my green line, I can test 0, 0. Okay, this is x plus y less than or equal to 180. And that's true. Okay, so I go to graph it. I have 0, 180. I have 180, 0. I'll connect these 2 points with a line. And I want to shade the side that contains 0, 0. Okay, so then our feasible region is going to be the region that is inside all of these. Okay. So that's this triangle in here. Okay. All right. Next, what we want to do is find the corners of our region. The maxes and mins of our objective function are going to be at one of the corners of our feasible region. Okay, and in this case, you know, I can kind of see what 2 of my corners are pretty easily. Okay, so this point here, I know my y value is 180 and the x value is 0. So I have 0, 180. This point here is 0, 0. Alright, and then this point here I don't know. So what we need to do is we need to find out what that is by finding the intersection of our 2 lines. So x plus y equals 180 and x equals 2y. So I'll just do substitution, plug in 2y for x in this top equation. 2y plus y equals 180, so 3y equals 180. Divide both sides by 3, and I get y equals 60. I can plug that in over here to get x equals 2 times 60, or 120, and I have this point 120, 60. And that looks reasonable based on my graph, right? I know, right, this is, you know, 120 looks about where we are, right, bigger than 50, okay, on the y's, so 60 looks about right. Okay, so I have these 3 corners. All right, our final step is going to be to test all of the corner points in the objective function. Okay, so I'm going to make a little chart, z, x, y, and I put in my corner points. So we had 0, 0, we had 120, 60, and then we had 0, 180. And our objective function was 8x plus 4y. Okay, if I plug 0 in for both x and y, 0 plus 0 gives me 0. Okay, so that's not going to be a maximum. Okay, so then we have 120 times 8 plus 4 times 60, and that gives us 1,200. And then 8 times 0 plus 180 times 4 gives us 720. Okay, so the maximum amount of money that we can raise is $1,200. x is 120, so 120 adults and 60 students. Okay, and that's how we go through one of these 7.5 problems.